All right, we are live, all the way live. Here we go. So let's look at this closely, not that close. And with this, rational expression. So when something is just rational, it has a ratio. A ratio is a fraction. So when we're dealing with rational expressions, we're really just figuring out how to be really more sophisticated in how we deal with fractions. The only thing that it gets more sophisticated with this is now we're dealing with expressions. So like an example of an expression is this right here. 2 times x squared times y squared. 2x squared y cubed. So that's an expression. And now the rational expression is this part where we have a fraction that we got to deal with. Okay. So the method that I'm going to teach to simplify, we're going to use the expand method. So the expand part is you take the parts of the fraction, you kind of line them up. So the numbers 2 and 8, these coefficients, I'm going to make that into the fraction 2 over 8. I'm going to take the x values and I'm going to make that a fraction. Since we're multiplying these values together anyway, we can say that the fractions that we break them into are multiplied and equal the same thing. So 2/8, I break that up. I put the numbers out together. And then x squared is x times x. X on the bottom, so I put x on the bottom. Times y to the third power, y, multiplied over y squared, y. So now that I look here, it's all expanded. Now I can start to cross things out. I can cancel things out because what does x over x equal? X over x equals x divided by x, 1, right? So watch, I can cancel that out because essentially it doesn't exist. I mean, it's just equal to 1. 1 times x is going to be just what's left over anyway. It doesn't equal 0. X divided by x is 1, so I can cancel it. I'm going to cancel this. That equals 1. Cancel that. That equals 1. So keep going. Do this along with me. And then I look here. I want to reduce this. If I have 2/8, what does that reduce to? They're both even. Let's divide both of them by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So 2/8 we know is equal to 1/4. So I'm going to go ahead and just cancel that 2/8 out. I just reduced it to equal 1/4. Okay. So you expand your rational expression. You expand it out. And then now you contract it. So expand, contract. You're going to expand it out, then contract it in. So now let's just put whatever we have left over. I'll do what's on the top first. We have 1 times x times y. So we have xy. On the bottom, what do we have? We have 4 times, there's nothing here, 4 times 1 times 1 times 1 is 4. So that is where I end up after I contract it back. xy divided by 4. Okay? So these are parts, the parts that are going to come into play here are what we learned about factoring, because when we factor, essentially what we're doing when we factor is taking out everything in common and seeing what's left over. Okay? So we're going to end up with, we're going to have a few problems like this. And actually, I want to do one more. So find space on your page or maybe after, somewhere else if you need it. Let's try this one. Okay, go ahead and split that up. You can either, you can keep it all in one fraction and just expand it all the way out, or you can do what we did up here and keep it, split up the fractions based on the parts. Okay, so let's go ahead and do that. Remember, we're making a fraction with our coefficients, making a fraction with our x values, the y values, and z values. We're going to bring it all together now. Okay, so I'm going to start to break it down. This is the expand part. Expand. So 16 over 4 times. We have x to the third and x times y times z, triple z. All right. So when you expand it, hey, if you don't like having the different fractions, I taught it this way so you can see that you could do it like that. If you want to keep everything on one fraction, you can also do that and just expand everything on the top and everything on the bottom. So this could be expressed as one huge fraction with everything expanded, or like we have here, multiple fractions. So go ahead and work through that. We're going to contract it back into one fraction after we cancel out what we can. Because remember, x over x is 1, y over y is 1, z over z is 1. So you can get rid of some of them, canceling them out. If you're confused right here, 16 divided by 4, that equals 4, right? So just remember, this is my hint if you forgot, remember that. Put it right here, put it in blue. 4 is 4 over 1. You might need that hint. Maybe that's a hint that's helpful. This is just a little hint. It's like a hint cloud. Okay, for those that maybe need me to work through it, keep work on your own if you're not sure, but if you need me to start working with you, let's do it. All right. So look, 16 divided by 4, we can divide 16 by 4, and we end up with just 4. I could take these x's and cancel them. I could take these y's, cancel them. I could take this z and cancel it. It's not really canceling it like it doesn't exist, but z over z is 1. And anything times 1 is the same thing. So it's kind of like z over z is 1. We don't need to necessarily think of it as anything but canceling, because we can cancel it out. It's equal to 1. All right, now let's work, get all the top ones here. Let's see, 4 times x. Those are gone, that's gone. So we get 4x squared. And then looking at the bottom, what do we have? We already canceled this 4 when we did 16 divided by 4 to get the 4 left here. 16 divided by 4 is 4, so there's nothing on the bottom, nothing. Yep. Z squared. Okay. All right. Give me a thumbs up, sideways down for doing this kind of stuff. Is it a nice intro day to like get back into the swing? Okay, good. All right. And tell me in the chat if your thumb sideways or you need another example. But we're gonna do a few of these, and the homework's a lot like this. Okay, guys. The only other trick I have to teach you is this next step here. All right, so take a screenshot if you needed this page right here, because I'm going to move it. Take a screenshot if you need it so that you have it kind of in that order in 3, 2, 1, boom. All right, next up to bat is simplifying this situation. Okay? Maybe you can see what the answer is going to be. If you can see the answer with your magic math hat, your genie hat on, that's cultural appropriation. I'll take that back. If you can see the answer, go ahead and throw it in the chat and let me know. It is something that you could put in the chat. It's going to reduce a lot. Now, you may be tempted to distribute. Don't distribute. We don't have to, because it's already been factored in a way that we're going to be able to cancel things out. Yes, Dave, perfect. Good job. Anybody else want to take a guess? There's no wrong guesses. Guesses are just guesses. Man, if there are wrong guesses, we're all in trouble. So take a guess if you want in the chat to figure it out. Okay. Let's look at this. What is going on with that? What that I just circled there in green. What? Okay. Not quite for the last answer there. What I want to point out is, look, x plus 2 over x plus 2. They're both expressions, but we can look at it as one thing because it's a quantity. It's a quantity. Everything in the parenthesis right here is a quantity. And look, these two quantities are exactly the same. You guys agree? The quantities are exactly the same. So I'm going to do a little baby step here. I'm going to say, well, look, x plus 2 divided by x plus 2, right? It's like if you divide the same thing by itself, right? 10 divided by 10, 1. X divided by x, 1. The same thing happens with expressions. X plus 2 divided by x plus 2 is 1. So I'm going to just put 1. That cancels out. All of it cancels out. It's not that the x cancels out and the 2 cancels out. It's this entire piece, x plus 2 and x plus 2. Because they're the same, we can take those expressions and say it can be expressed as 1. So now I end up with 3 over 6, and that can reduce to what? 3 over 6 reduces to 1/2. Because you can divide by 3, you can divide by 3, you get 1/2. Okay, so here's our answer. I think it's just like a matter, you got to be told you can do that. Okay, you can do that though. So watch this. If you had x squared plus 17x minus 3 over x squared plus 17x minus 3, what's that equal to? Show me on your hand. You only need one finger to show it. Yeah. This is the same as this. It's just a bigger expression. It's exactly the same on top and bottom. So we can say, well, you know what I can do? Since these are the same, exactly the same, this is equal to 1. Okay? So I want you to know, even when the expressions get really complicated, if I wanted to really show this in class, this is what I would do. I'd write an expression that's like 15 terms, and then a fraction, the same terms underneath, just to be obnoxious. And then you'd see that it's the same on top and bottom, so it's equal to 1. Okay? Anything over itself is equal to 1. Okay? Now, we're going to keep going. There's some things I'm going to be adding as we look through these lessons. There's some other kind of like little points that I'll bring up, but mainly, good, James. Mainly, that's how we're going to approach this. So we need to have one more tool in our belt, and that is no. Yes. No. Jeez. I had like a space satellite trying to look at a playing card. All right, look. X method. Who has heard of the X method? Santana, you better raise your hand. I know Geneva's seen it. We did it last year. Have you all used the X method in math too? Okay, tell me in the chat if you just haven't. And it'll just help me. I won't call you out. I just want to know if I need to explain it in a little more thorough fashion. I'll do it thorough anyway. Okay. If you don't remember using it, okay, that's no problem. Maybe you guys had Stodmore last year, or okay, maybe you have, maybe you haven't. Okay, so there's some people that haven't, so I'm going to teach it as if nobody knows it. So if you know it, just pretend like you don't know it. All right, here we go. So look, when we want to factor a trinomial, and the reason we're going to do that is we want to set up where we have two expressions, and hopefully if we have like we had up here, like when we had a fraction, a rational expression, we're hoping to factor it into two expressions so that we'll be able to cancel one of them out. That's the name of the game. That's why we're going to do it, okay? So look, we are going to look at this expression here, x squared plus 5x plus 6. And we're going to factor it using the X method. So the first steps, ID, identify, A, B, and C. Now, A, B, and C, here's A. Here's B, positive 5. Here's C, positive 6. Okay. It's just going to be the coefficients, and C is always that constant that kind of hangs out in our trinomials like that. So everyone okay with finding A, B, and C? I mean, honestly, once you get that, you just got to put it in the right place. Excellent. Thanks. All right. So now what we're going to do with this, we're going to make a big X. Set up your X. Man, step 2 is easy. I love step 2. Set up your X. It's like a game, okay? It's like a logic game here. All right. All right. Okay, look, what we're going to do is this. I want you to put a little B right there in the top box. I want you to put a little C right here in the bottom box. Okay. And now all you have to do is put those values in those boxes. So look, my B value I already figured out. B always goes on top. One way to remember this is B comes before C, so it's kind of it's in order in a way. If you can see that order, sometimes the spatial positioning, if you establish that, then you'll always remember it. B, then C, so I'm going to put my 5 here. I'm going to put my 6 here. They're both positive. I'll leave that positive out, though, because I know it's just positive. All right, now here's the name of the game. We need two numbers right here. Two numbers that are going to add, go ahead and write add, to give me 5, and multiply to give me 6. We need two numbers that add to give you 5 and multiply to give you 6, okay? And if you're like, James, right on, got the two values really quick, maybe you got the answers really quick, it's going to be a little trickier if this is a harder number to deal with or if it's negative or, whatever's going on. So here's how I would figure this out if I didn't know how to do that. I would say, okay, well, what is 6? 6 is 6 times 1, 1 times 6, 2 times 3, 3 times 2. There's negative options, -2, -3, -3, -2. Don't do all these every time. You probably won't have to make such an extensive list like that every time because you're going to see the answer quicker, okay? But if you can't figure out, you always look, if you can't figure out what the multiply part is, how to get 6, you can just put all of the multiples, the factors of 6, 6 times 1, 1 times 6, 2 times 3, 3 times 2. All those numbers have a product of 6, multiply to give us 6. And that's what we're looking for. So this is kind of like, step 3, 3B is right here. This is like step 3B. Okay. So we're going to set it up like that. And then which one of these two, when you add them together, 6 plus 1 is 7, 1 plus 6 is 7, 2 plus 3 is 5. That works. 3 plus 2 is 5. You don't have to, it doesn't matter which one of those you choose, but these work. That one works. So watch. +2, +3. We'll do a few of these. Don't worry. Don't worry. With all this like written in, it gets a little harder. But when we do the next one, it'll be more straightforward, okay? So look, 2 and 3 work. Whatever goes here, we're going to input the answers into the quantities. Watch what I do. It's +3. It's just going to be x plus 3. That's 2, isn't it? That's a 2. 2 plus 2. I promise I went to college. That's a +3. X plus 3. Okay? And look. Done. We just did it. ID is identify. Just like you carry your ID around, identify. So we already learned how to go from here to the trinomial by doing FOIL, right? X times X, first, outer, inner, last. And you can always double check yourself. That's why I like this unit, because everything that you do, you can always double check yourself to see, well, if I multiply these quantities together, do I get back where I started? You would, okay? And that's how you'll be able to double check yourself, okay? All right, let me know. I'm going to do another problem, but let me know right now, especially for the newbies. Thumbs up, sideways, down. Just write it in the chat if you don't have it. Thumbs up, sideways, down. We're good? Yeah. Give me some sideways if it's sideways, though. All right, good. All right, we're going to do another one. Let's move it up. All right. So we'll get to that last example 4 in a second, but let's just do another. All right, I want you to factor this one. Just kidding. Haha, never happened. All right, how about okay, now I'm just thinking too much. Okay, this one's a little more complicated, but we're going to end up with an answer exactly how we end up always. So, step 1, identify A, B, and C. You know what? You don't have to write it out. You can just say this is A, that's B, that's C. You see? You can make it a little bit easier as we do our second problem here. You don't have to write all the little details. Step 2, set up your box. You can put a B and a C there until you remember all of it. Remember, we're going to be adding to get our B. We're going to be multiplying to get our C. So go ahead and put those values in those boxes. Oh my. Close, James. Close. We have 12. This is why it's harder. This is why it's harder. Here we have -8. Ah, that's why. All right, Hunter, good job. All right, so we got this far. Now we got to do our kind of 3B, our 3B kind of part here. I want to see, well, 12. Write out all the ways to get positive 12. What do you multiply to get positive 12? Well, I'm going to do 12 and 1. How about this? This is my hint. -12, -1. Oh. So go ahead and fill out the rest. What multiplies to give you positive 12? Keeping in mind that 2 negatives multiply to give you a positive. Bad mood, good date. How do we get that 12? There's a bunch of options. Whoa. Okay. Okay, James, make sure that what you're saying there is the answer with this. I'm slightly confused, but I trust that you're working hard here. The last one came pretty quick, so maybe we can get this one too. All right, 12 is, look, 3 times 4. And what else I got to put in there? -3, -4. 12 has a lot. 6 times 2. I'm not putting 2 times 6. Is everyone okay with me not doing 2 times 6 and 6 times 2? Right? 6 times 2, 2 times 6, but I can just keep these. That's fine. -6, -2. Ooh, all right, all right. Let's see, which one adds to give us -8? This adds to give you 13. That adds to give you -13. That adds to give you 7. This adds to give you -7. This adds to give you 8. This adds to give us -8. So this is the way we're going to find what we're going to combine here. So I like to just put these boxes here so I remember, yeah, that's what I'm looking for. Okay. Okay. And then go ahead and take that exact amount and put it here. -6, -2. Done. Not bad, right? Not so bad. Not so bad. Okay, okay, okay. Let's go ahead and try the next problem then. All right, take a screenshot if you need that. That has both the X method problems together. That might be helpful when you need to study, your screenshots when you're doing homework. So go ahead and take a screenshot if you need it in 3, 2, 1. Boom. All right, here we go. Now we have this situation. And I'm going to tell you, anytime you see this kind of situation, we know we're going to end up wanting to factor that bottom trinomial. We want to factor the bottom trinomial. And I'm going to tell you, the hint is, I'm guessing one of these bottom quantities is going to be the same as what's on the top. I think one of these on the bottom is going to end up being x minus 5. X minus 5 we can just leave on the top. There's nothing we can factor. We can't do anything with that. So I'm just going to put it there. But do you see how like it's like test maker's cap, put your test maker's cap on. You could see that likely what we're going to try to do is factor the trinomial so that it's two expressions. And one of the expressions is going to be x minus 5 so that we'll be able to cancel it out. Otherwise, they're not giving you a problem you could solve. Okay? The problems in your math book are solvable. So keep that in mind. Anything on tests, put on your test maker's hat and figure out, well, what are they trying to make us solve? Because they don't just give you random numbers. They give you numbers that you'll be able to solve. So I say what we're going to do is take this x squared minus 3x minus 10, and we're going to factor it and put it into the quantities in the bottom. So go ahead and do our steps, our same steps that we did before, labeling A, B, and C. Label A, B, and C. Do you guys want more leeway on this? Do you guys want me to give you like a few minutes to try to do it? Yeah, I'll do that. Okay. So go for it all the way, start to finish. What are we doing again? We're factoring the trinomial into two quantities, two binomials, so that we can hopefully cancel that x minus 5. Let's see. Okay. 3. Yep. Good, James. Yes. This one is even a degree trickier. It's a little trickier. Because how you multiply to get negative 10, you have to multiply positive times a negative. So you're going to have to put more options for the negative 10, just a hint. But as promised, I'll let you do this. I won't interrupt. And when you're done, maybe try to test your ability to tell me in the chat what is your answer. You'll have to express it as a fraction, but let's see if you can do it. And that'll let me know maybe it's time to start working on it. Alicia, that's really, yep. Wait, right what I was going to say. Yeah, you know. Okay. Yep. So yeah, that looks good. Yep, Alicia, you got it with that plus change. Good. Okay. Good job. All right, I see some people wrapping it up, so I'm going to start. If you're a little confused, maybe take a break, notice where you got stuck, and then let's see if we can notice what is different from how I'm going to do it. A is 1. B is negative 3. C is negative 10. Okay, so when I go and I'm about to do my X method, I'm going to put B on the top, C on the bottom. Now remember, we need to multiply to give us negative 10. We got to add to give us negative 3. So watch, I'm going to do my negative 10 kind of breakdown here. I'm going to say negative 10 and 1. This is where you do have to do all the options like this, because you see I can't just express that as one option. Because when we combine them, you know it's going to be different. Okay, I think you guys get that. 10, so what else do we have? 5, negative 2, negative 5, positive 2, and that's it. Those are all of them. Now, this is where it's a matter of being really careful here. We know we needed them to multiply to give us negative 10 and add to give us negative 3. So let's see. When we add these, we get negative 9 when we combine these. Here we get positive 9 when we combine these. Here we get positive 3, 5 minus 2. Here, negative 5 plus 2, we get negative 3. So I like that. I like that. Negative 5, positive 2. Oh. You see how at this point you're like, I'm on the right track. Before I even put my numbers in this expression, I know I'm on the right track. Maybe you could start to see that. X minus 5. Oh, yeah, look. X plus 2. I know I've done this right. Test maker's hat. Put it on when you're doing homework and tests because they'll always make it possible for you to get to the end. Okay? These are exactly the same. So those combine to give us 1. Okay? My answer then is 1 over x plus 2. Done. That's almost as hard as it's going to get. Might get a little trickier. All right. As you wrap up that question and maybe fill that in, let me set up one more problem for us. Let's do one with positives though. Okay. That's going to be 6. All right. Whew. One more for you. Last one. I haven't put it like that for us. There is one additional step we have to do for this problem. This problem right here. Now, what's different? Okay, no problem. See you Thursday. All right. All right. Okay. So what's different? Somebody just tell me what's different. What's different? You could even do maybe a letter's different. Yes. There's a 2 out here. There's a 2 out here, right? We actually can't do the x method unless our a value is 1. So guess what we're going to probably have to do right now? We're going to have to factor out a 2. Okay? This is probably the hardest it's going to get here. Okay, so watch. I know it's x plus 2 on the top. That doesn't change. But look, I want to factor out a 2 from each of those terms. Essentially what I want to do is I want to divide out a 2, divide out a 2, divide out a 2. So divide out a 2 from all of those terms, and then the 2 is out front, and we have a trinomial we can deal with. You catch that difference? It's just a little different, right? Test maker's hat. If there's a 2 out front, they're likely going to make it so we can divide out a 2, divide out a 2, divide out a 2. And they're all even, so we can. I don't believe we go any further. There is a super x method, but I don't think we need the super x method for this stuff. We'll see. I don't think in this lesson, no. Okay. Two x squared divided by 2. If we divide out of 2, what's left over? X squared. 12x. We divide out of 2. What do we have? 6x. 16. Divide out of 2. What's left? Positive 8. You see? So now, what I know, what I'm going to end up with is that x plus 2 on the top, I'm going to have a 2 out front. And what I'm doing now is using the x method to go from here to 2 expressions. So you see, it's just like another little prep step we have to do, and then it's the same process. We're going to be able to cancel and end up with our final answer down here after we were able to cancel. maybe I'll even write that here. X method only with a is equal to 1. It's kind of like one of our limits for this tool. We have to have a is equal to 1. Not quite. All right, so what we're all doing right now is taking this expression here, x squared plus 6x plus 8, and we're taking that and doing the x method with it. So it's almost like how I had the problems up here. We started with a trinomial. Now I'm pretty much forgetting about everything else. I'm forgetting about everything else because my only goal right now is to factor this the red expression here. I'm trying to factor it into 2 expressions so that I'll be able to cancel some stuff out. So kind of like you have to think big picture and then just keep switching it. So now you're thinking small picture. Now you're just dealing with one part of it and working there. 4 and 2. Yeah. So yeah, you got it. And then throw that in those expressions. A is 1. B is 6. C is 8. Let's put our 8 here. Let's put our 6 there. Okay, James, you're on the right track. Those answers, though, that you're saying, those go in these expressions, and we have one more step after that. Okay, good. But for this, you're right. That's what our answers are going to be for these boxes. I think you knew that. 8. It's positive 8. So we have 8 and 1. You know, I'll put it in there, negative 8, negative 1, but that's not going to be the answer because we end up with a positive 6. I know that's not right. So 4, 2. Oh, okay. Negative 4, negative 2. All right, which one of these adds to give us 6? That guy. 4 and 2. Add to give you 6, multiply give you 8. So I have positive 4. I have positive 2. Let's go and do it. X plus 2. I just put it there because it's easier to finish the problem that way. It doesn't matter which one goes first, this expression or this expression. It doesn't matter where you put the 2 and the 4 as long as they're multiplied expressions here. The 2 quantities. It doesn't matter the order. 3 times 2, 2 times 3, 6. 3 times 2, 2 times 3. Doesn't matter which order when you're multiplying. Okay. Whew. Now, last step. That sure looks nice. That looks like it's the same thing. See ya. All right. There's still a 1 left on top. It's not 0 up there, right? Because this is 1 times 1. We could say, well, there is a 1 on top. We could say that. So what's left over on top is 1. What's left over on the bottom? Nice, James. 2 x plus 4. All right. That's as hard as it gets, guys. Not bad, right? There's a method to it, the X method. Make sure that you're just following the steps. And this was kind of test maker's hat. I looked here. Oh, I can't use the X method when the A value is anything but 1. So I'm going to work hard to make that 1. Just divide it out. Divide it out, divide it out. Divide it out of 2. That was what left over. A, B, and C, X method. We figure out that it's going to be positive 2 and positive 4 canceled. 1 over 2 times x plus 4. And there's no need to distribute this down here. I want you to keep it just like this, okay? There's really, for an answer, no need to distribute it out. Keep it in that factored form, all right? Mm-hmm. All right, give me a thumbs up, sideways down, for those I can see. For those in the chat, thumbs up, thumbs up. Okay, all 3 for the visual. Anyone in the chat, thumb sideways or need to see another? I actually think that's a pretty... that's a rounded lesson there. It rounds out all we need to learn. Okay, now I'll stop the video. Thanks for watching.